A good day to you all. So welcome to my presentation of final thesis. I am Mithushree Bandarani and I'm reading my master's in field of cybersecurity and forensic. And my research area covers the cryptography field and including the encryption and decryption part. So let's proceed to the presentation with me, right? So the first thing that I have is the outline of the presentation. First, before we directly moving to the solution, I'm going to give a brief introduction about what is cryptography, and secondly categories of cryptography, and then we will move on to the solution. And fourthly, the explanation about the product or the prototype and the workflow of the product and the main field or the categories that we can apply this solution and the current requirement this project is related with. And also I have included few demonstration or the requirement demo for all you to understand in detail in advance, right? So first, let's take a look at what is cryptography. As per the Kaspersky, they said cryptography is the study of secure communication techniques that allows only sender and intended recipient of the message to view the contents. In other words, the communication between two people or two destinations in secure manner. So if someone need to communicate in a securely or pass some message to some other location insecurely, that's what is called secure communication is what is called cryptography. As an example, daily what we experience is the postal service. So the postal service also can take as a example for the secure communication. As a, like we send a postcard. So when we send a postcard, we write receiver's address and the sender's address as well as the content. So it is a way of communicating secure manner. And there is another way of communicating. We can use register post mail, or that way it will deliver quickly as well as it will secure more. So those are two examples that we can take in real world to explain the cryptography. So the secure communication techniques, study of secure communication techniques means the study of cryptography. So in the cryptography, what's expected outcomes are confidentiality, non-repudiation, and authentication, access control, and integrity. So these things should be included in the cryptography field as per this diagram also, that you can see the importance of the these aspects, right? So let's move on. So in the cryptography, in the IT related cryptography, we have two categories of cryptography. So first one is asymmetric cryptography. So second one is symmetric cryptography. In right hand side that you can see the asymmetric cryptography. In here what happened is they don't have single key or the single way of securing the communication. They have two security countermeasures are taken in order to secure the communication. Those two are they have private key and the public key, which means we send some message by using some publicly available key or the address, and the receiver will find out or the decrypt, or they will get the information by using their own personal key. So it's something like the content is sending via postal services. So those are publicly addresses available. Is private key is something like internally they have categories. These are the categories, these are the department, this mail forward to something like this. So those private departments or the private things are available within the internal system. It's something like that. When message received to the system, they have a separate set of key to decrypt those messages, right? So the person who send the message will encrypt their message using the public key, and when it received to the receiver, they will use separate or the unique another key to decrypt those messages in order to get the original data. So that is what is called asymmetric. So let's move on to the second category of the cryptography is symmetric. Symmetric means the both keys or the both communication securing keys are the same. So they are using same method or the same key in order to secure their document. As the example, when we are sending some message to some other party, we will encrypt or we can hide this data by using single techniques. So there's technique or the same way the other person can get the key and decrypt the message. So that is what it is called symmetric. So in here there is a security issue is also there because we need to share the same key. It's like a locker. So when we are sending some to another person, we are sending some other lock or the box locked parcel to another person, we need to send the key also. The same key is the only one we can able to unlock that particular box. So the key should be shared between two parties in order to decrypt or take the original message. So when in the symmetric there is a problem because the sharing the key or the sharing the method that to be decrypted is a unsecure channel. So that is something when it's come to the symmetric. So now they have introduced the hybrid model, which is hybrid model to the symmetric encryption, which is include the symmetric encryption and the asymmetric encryption all together. So when they are encrypting in a symmetric model, they will use asymmetric tunnel or the communication method to send the key to the destination. So by using asymmetric cryptography, they will send the key to the other party. So it's kind of a little bit slow, but when it's come to the symmetric, it's very fast. But when it's come to asymmetric, even it is secure, but it is a little bit slow in decryption, right? So let's move on to the solution, which I have applied and developed. So this solution is called Puzzle 2.0, which is an enhanced encryption for already existing encryption symmetric algorithm. So why do we need this kind of solution? So the requirement to fulfill is the symmetric algorithms are secure and fast. The only problem that realized there is the communication or the sharing key. So if they don't have to share the key, that will be very easy, it will be very fast to decrypt the data. So that's very plus point in our security field. And also we can secure those messages by using this asymmetric algorithm as well. So security is improved, does not require any key to sharing, and the fast decryption is also available in this particular solution. So if we can develop this symmetric algorithm to avoid the sharing key, so if we can use some other method techniques, the symmetric algorithm will be great opportunity or great solution for encryptions as well. So this is why I have produced this particular algorithm. So in this algorithm, I have used AES encryption algorithm. But in here, what happened is we don't share any keys. So in Puzzle 2.0, we don't share any keys in like symmetric algorithm. We only encrypt the data and send it to other party. There will be some things that require to decrypt. So let's see what are the things and how this Puzzle 2.0 is working, right? So how does this work? If we are not sharing any keys, what is the techniques that work behind this particular algorithm? So what happened here is there are three parameters that taken into this algorithm when they are encrypting the data. So those things are the time and the location and the password. So three things are there. So when someone need to encrypt some data and send it to another person, basically what we have here is we are asking for three parameters. The first one is the GPS location of that particular user. The second one is the time that need to be decrypted, the particular time, and the password for that particular document or the message. So these three things will be combined and work together and encrypt the message, something like here. So this sender uh, going to send some data to these receiver 1 and receiver 2, two separate users. So they are using password and destination locations. So this receiver 1 location is different and receivers 2 locations are different. And destination time, the time can be same or different. So the location is different, should be different at the time. And password can also be the same. It doesn't matter about the password, even they have the same password, but they are going to have the separate set of location or time. So the parameters won't be able to complete. And the data, so the user input, this user input can be a message or the document, whatever the things that you need to secure, right? So and these things are included to the inserted into the algorithm, and within the algorithm itself they are going to encrypt that particular data as per the locations and the destination locations and the destination time with the preset password, right? So the first encrypted message with the receiver 1 will send to the receiver 1. So in order to decrypt this particular message, the receiver need to have the password. And the rest of the part, GPS location or the destination location and the destination time or the time will taken within itself by the API, Puzzle 2.2 API. So directly connected the real-time module or the NTP server or GPS location service to the API, which is Puzzle 2.0. So when they are about to decrypt, what the Puzzle 2.0 will do is they will get the current location as well as the real time, and both those things together and with the input of the user with the password, the algorithm will be able to decrypt. So there will be no interruptions between those two because API itself, it is connecting with the system. Right. So let's move to the second part. The second one is also the same. The sender send the data to the another receivers too, but their own location with with their own time and own password. So totally different. Even the password is the same, that won't be any problem in this particular scenario. So you can get the data, and when it is about to decrypt, the API Puzzle 2.2 integrated API will get the GPS module, will connect with the GPS module and get the current time, get current location and the time. So both things together with the input of the user with the password, so they will able to decrypt the password, right? So this is how this Puzzle 2.0 will work. So this is the workflow that I am about to show you is the workflow of the Puzzle 2.0. So the work here is what happened here within the API is the original data. It can be a text or the file or the document, whatever the things that you need to send. And those things inserted into the encryption, and within the encryption itself get the location or the destination location and the destination time and the password which is user input, and it will encrypt as per the destination location and destination time and the password, and after that we can send it via any communication channel to a destination. Within the destination itself, what we are going to have is the when it's come to the decryption part, and Puzzle 2.2 will connect with the GPS module, get the time, and time will be taken, and the password from the user. So after getting this all three parameters together, it will decrypt the message. If those things are correct, the three parameters are correctly tallied with these particular parameters which is set previously, it will definitely decrypt the message, and they will be able to get the data in here, right? And the final or the applying part for this particular solution is a this solution can be applied to mainly for this particular area, especially examination, which is a current requirement. This project is developed for this purpose as well. And another one is the bank, because they are sending so much critical data to the customers as well as within branch itself, and interbank communications are also there. So for them, they can use this kind of solution. And for the military, of course, because they are having also sensitive and national defense related stuff, so they can also apply this particular solution as well. So on particular location, they would be able to get the work done, or they would be able to decrypt the encryption itself. And for the current requirement, this research area was selected to apply the solution to the National Department of Examination as per their current requirement. So there is a current requirement in National Department of Examinations, which is I am currently involved in. So that is this solution is about to give them as a solution for their examination process. Right. So I have developed kind of a small video which is related with the 15-second. I think which is it is not relevant to. It's not good to show you in here, but I will. Okay, so that's it about the requirement demonstration. So thank you very much for staying with me throughout my presentation. Thank you very much and have a nice day.